Today we're going to be condensing logarithms. So we're going to go from our expanded form where we have addition, subtraction, and coefficients in front of the logarithms back to multiplication, division, and exponents. Let's take a look at example 1. On example 1, I have log base 5 of 7 plus 3 log base 5 of x. So since we're working our way backwards, one of the last things that we would always do would be to move our exponents in front of the logs that they belong to. On this one, we're going to actually move our exponents first. So this 3 is a coefficient in front of the log it belongs to. We're going to actually move it back as an exponent. So I'm going to rewrite this as log base 5 of 7 plus log base 5 of x cubed. Now I have a log base 5 on the 7 and a log base 5 on the x cubed. Because there's addition, I know I can rewrite this into multiplication. We write our log base 5 one time, and we're going to get this 7 and this x cubed, and we're going to multiply them. So 7 times x cubed. Well, I know 7 times x cubed is 7x cubed, so the condensed form would be log base 5 of 7x cubed, and this is the condensed form of that logarithm. Let's take a look at example 2. On example 2, I have log base 2 of x minus log base 2 of 3. If I was going to condense this, the first thing I'm going to look for is any exponents. I don't have any exponents. So the second thing I'm going to notice is that I have a subtraction sign. Anytime there's a subtraction sign, I know I'm going to have division. I write my log base 2 one time. And whenever I have a fraction, I know that anything that had a positive log in front of it will go to my numerator, and anything that had a negative log in front of it will go to my denominator. So I had an x that had a positive log in front of it, so the x goes to my numerator. And I had a 3 that had a negative log in front of it, so my 3 goes in the denominator. So here's the condensed form of my logarithmic problem. On example 3, the first thing I'm going to look for is exponents. On this one, I can see that I have 2 exponents. I have a 1/2, so I know I'm going to put this 1/2 back as an exponent on my m. I also notice that I have a 3. Now, look, if you're looking at this, you notice that I did not circle the negative sign, because the negative sign tells me that I'm going to have a fraction. Now, I'm going to rewrite this so it has its exponents. I get log base 6 of m to the 1/2, and then minus log base 6 of n cubed. Now, if you remember, we said that whenever we have the expanded form, we always wrote it as rational exponents. But when we have the condensed form, we're always going to write them as radicals. So I'm going to go ahead and I'm going to rewrite this. So I'm going to do power over root, and I'm going to rewrite it so I have my radical. So whenever I do that, I have log base 6 of the square root of m minus log base 6 of n cubed. Now I'm condensing further. Whenever I condense further, I write log base 6 one time. Since there was a subtraction sign, I know I have a fraction. The one that had the positive log in front of it goes in the numerator, so that's going to be my square root of m. Whenever I have the negative log in front of it, I know that's going to my denominator, so I'm going to put my n cubed in my denominator. And now I have log base 6 of the square root of m divided by n cubed. And there's my condensed form. On example 4, there's 2 ways that we can do this. Now, usually when we have a number outside the parentheses, we go ahead and we distribute it. So I'm going to show you that way. I'm going to say, okay, this 3 can go in front of the log base 2 of a. And then this 3 can go in front of that log base 2 of b. So I would end up with a negative 3 log base 2 of b. So I have 3 log base 2 of a minus 3 log base 2 of b. Now, whenever I condense it, I'm going to put my coefficients back as exponents. And I end up with log base 2 of a cubed minus log base 2 of b cubed. Once I have log base 2 of a cubed minus log base 2 of b cubed, because of the subtraction sign, when I condense, I know I'm going to have a fraction. I write the log base 2 one time, and I write a cubed in my numerator, and my b cubed is going to go in my denominator. So that's one way that we can write this. Now, another way that we can work this out is if we actually work what's in the parentheses. So if I wanted to, I could actually do what's inside the parentheses first. If I were to do what's inside the parentheses first, I see that there is a subtraction sign. So I would have 3 parentheses. I'm going to condense what's inside the parentheses first. So I have log base 2 of, and there's a subtraction sign. So I know I need a fraction. The a has a positive log in front of it. So I put the a in the numerator. And the b has a negative log in front of it. So I put the b in the denominator. And then I close my parentheses. So now I would end up with 3 log base 2 of a divided by b. Well, I'm going to get this 3 and I'm going to put it on the a divided by b as an exponent. So I would have log base 2 of a divided by b, where all of it is cubed. This is another way that we could rewrite this problem. Both of these are correct condensed forms. On example 5, whenever I look at this, I can see that I've got some exponents and I have additions and subtraction signs. Let's work with our exponents first. So this 3 is going back on the m as an exponent. This 2 is going back on the n as an exponent. So when I rewrite it, I have log base 3 of 4 plus log base 3 of m cubed minus log base 3 of n squared. Now, whenever I condense, I know that I have to write log base 3 one time. I know that we will have some things that are being multiplied, and I know that we will also have a fraction. So I'm going to go ahead and I'm going to write my fraction bar. And if you remember, anything with a positive log in front of it goes to the numerator. So I have a positive log base 3 in front of my 4. So my 4 goes to my numerator. I have a positive log base 3 in front of my m cubed, so I know my m cubed is going to go to my numerator. And then I have a negative log base 3 in front of my n squared, so I know my n squared is going to go to my denominator. So here is my condensed form. Thanks for watching as we condensed logarithms.